find the distance between the point 1, -2, 4 to the plane 3x plus 2y plus 6z equal 5. There are two ways of doing this, a short way and a little bit longer way, and I'm going to show you both, and it is up to you which way you want to do this. The short one, the one that I usually do this is I'm going to use the formula that distance equals absolute value of ax1 plus b times y1 plus c times z1 plus d all over a to the second plus b to the second plus c to the second. Okay, so what is a, b, c? What is x1, y1, z1? x1, y1, z1 comes from the given point. So this is my x1, this is my y1, this is my z1. And a and b and c are the coefficient of x, y, and z. So this is my a, this is my b, this is 6 is my c. Now, since 5 is on the right-hand side of the equal sign, this is going to be my minus d. So, notice that if this was 3x plus 2y plus 6z minus 5 equals 0, then 5 would have been my d. But now that's on the other side of equal sign, so I have to consider that, and 5 is minus d. Okay, let's just plug in the numbers. So d equals 3 times 1, absolute value of 3 times 1, plus 2 times -2, plus 6 times 4, and plus d, and we said that, so d is minus d is 5, so d is -5, and all over square root of 3 squared plus 2 squared plus 6 squared, and that equals, let's see, 3, then I have -4, then I have 24, then I have a -5 over square root of 9 plus 4 plus 36. So that's going to give me on the numerator -18, absolute value of that is +18. On the denominator, I have 49, square root of that is 7. So unit, okay. So 18 over 7 unit is the distance between the given point and the given plane. Now, I'm going to go ahead and do this slightly in a longer way. Go to the next page. So using the formula that distance equals absolute value of PQ dot n over magnitude of n. Okay, so what is n? N is my normal vector. So 3, 2, 6. Well, actually, 3, 2, 6 is my directional vector. Let's call it n. You could call it anything you want. And of course, I need a point. I'm going to just put in parentheses, just any point on the plane, Okay, so let me go ahead and go to the next page. If I so the plane is 3x, the equation of the plane is 3x plus 2y plus 6z equals to 5. If I let x and y to equal 0, both of them, then I would get 6z equals 5 and z equals 5 over 6. So the point 0, 0, 5 over 6 is on the plane, on the plane. Okay. The Q is given to us. Q is 1, -2, 4. Okay. So what is PQ? So the vector PQ means, let's see, I get a 1, a -2, and a 19/6. Well, how did I get 1? PQ, so it's going to be 1 minus 0, -2 minus 0, and 5 minus 4 minus 5/6 gives me 19/6. So PQ is that, and D equal absolute value of 3 minus 4 plus 19, which is the dot product of PQ dot n over magnitude of n, which is square root of 3 squared plus 2 squared plus 6 squared. And so that again, as you can see, 3 and 9 is 22, minus 4 is 18. The absolute value of that is 18. In the denominator, I get 9 and a 49. Square root of that is 7. So I got the same answer. So a natural question here to ask is, I mean, can we do any convenient point? How did that happen? And so here's, just explain. So let's say that you have a plane in here and you have a point in here, okay? So the shortest distance, or the distance you are interested is go to this plane, is if you drop a perpendicular, that's the distance. Now, let's say that if you find a point, any point on the, let me change color, let's say a point in here, any point on the plane, notice that this vector, so let's say this is P, and actually in this case, that naming doesn't matter, PQ. So, this is going to give me a vector right here. And the vertical component of this green vector is going to be the magnitude, or the distance between the given point and the plane. So let's make a right triangle out of this. Okay, so that is why it really doesn't matter where do you pick the point. So let's say that if this is the same plane, and let's say if this is the same point in here, let's say if you pick a point, again, pick a point like this time here, okay, you can make a right triangle out of this. And here's a vector. Okay. And the vertical component of the black vector is this distance from the point to the plane. Okay, if you need more explanation, or you need to see the proof of that other than what you have in your textbook, email me.